All right, let's dive right in. Look, we all work with JavaScript objects pretty much every single day. But how often do we stop and think about what's really happening under the hood? Well, today we're going to peel back those layers and explore the surprisingly powerful world of property descriptors. I think you'll be amazed at how much control you can have over your object properties. So here's our game plan. First, we're going to move beyond the simple key value pairs we all know and love and really dig into the property descriptor itself. Then we'll get our hands dirty with some code, figuring out how to control property flags, how to handle that powerful configurable flag, and even how to lock down an entire object. We'll wrap it all up with a really practical technique, creating a flags-aware object clone that'll make your code way more robust. Okay, this line of code, we've probably all written something like this 1,000 times, right? It's the absolute bread and butter of JavaScript. You create a user object, give it a name property. It's simple, it's clean, it works. But what if I told you there's a whole lot more going on here than meets the eye? I mean, have you ever been in a situation where you really needed to make a property read-only? Or maybe you needed to stop a property from being deleted no matter what? These are pretty common scenarios in real-world apps, and the solution lies in understanding this hidden metadata that JavaScript attaches to every single property. To unlock all this hidden power, we have to talk about a new concept, the property descriptor. The best way to think about it is like a blueprint for your property. It doesn't just define the value, but also a set of special flags that control its behavior. Yeah, it's like having a dedicated control panel for each and every property in your object. So how do we actually get a look at this blueprint? Well, JavaScript gives us a really handy tool called object get owned property descriptor. I know it's a bit of a mouthful, but it does exactly what it sounds like. It gets the property descriptor for one specific property on an object. All you have to do is pass in the object and the property name, and it spills all the secrets. And boom, here's what we get back. It's just a simple object with 4 key value pairs. We've got the value, of course, that's John, but the real magic is in these 3 flags, writable, enumerable, and configurable. When you create a property this way, they're all set to true by default. And that's exactly why you can change the value, loop over it, and delete it with no problems. But what happens when we start flipping these switches? Now that we can see these flags, it's time to take control. We can use another method, object.defineProperty, to create properties with totally custom behavior. This is where it gets really fun. Let's break down what each of these flags actually does and how we can use them. First up, we have writable. This one is pretty straightforward. If it's true, you can change the property's value. If it's false, that property becomes read-only. Honestly, just think of it like a file permission. You either have write access or you don't. Simple as that. Let's actually see this in action. We're going to use object.defineProperty on our user object, and we'll target the name property. Then we just pass in a little descriptor object and set writable to false. That's it. It's really that simple. So what happens now? Well, if we try to change user.name to Pete, we're going to get a type error. Now, this is really important. That error only gets thrown in strict mode. If you're not using strict mode, the operation just fails silently, which can be a nightmare to debug. This is just one more reason why you should pretty much always be using strict mode. And just like that, we've made a read-only property. Okay, next up is enumerable. This flag controls whether a property shows up in things like a for-in loop or when you call object.keys. You ever wonder why you don't see methods like toString when you loop over an object? Well, this is why. They're non-enumerable by default. It's a really clever way to keep your loops clean and focused only on the data you actually care about. And this is a perfect use case for that enumerable flag. Let's say we add our own custom toString method to the user object. By default, it would show up in our loops, which is probably not what we want. To make it behave just like a built-in method, we can just set its enumerable flag to false. This is a great little trick for creating really clean, professional APIs. And here's the result. Before we made our change, looping over the user object would give us both name and toString. But after setting enumerable to false, poof, the toString property is hidden from the loop. It's still there, of course, you can still call it, but it just doesn't clutter up our enumeration. It's a small change, but it makes a huge difference in the clarity of the code. All right, now we come to the most powerful and, well, permanent flag of them all, configurable. I like to call this the point of no return, because once you set this thing to false, there is no going back. Seriously, it's a one-way street, so you need to be absolutely sure before you make this change. So what does this point of no return actually mean? Well, when configurable is false, you can no longer delete the property, and you can't change its other flags. You can't make it enumerable again, and you definitely can't switch configurable back to true. You are essentially locking down the very definition of the property. It's an incredibly powerful tool, but you have to use it with caution. This right here is the key takeaway, and it's worth repeating. A non-configurable property can't be deleted, and its attributes can't be modified. This is precisely how JavaScript protects fundamental built-in constants that should never, ever be changed. It's the core mechanism for creating truly immutable properties. So how do we create a true unchangeable constant, just like math.py? The answer is you combine writable false and configurable false. This little dynamic duo creates a forever sealed property. It can never be changed, never be deleted, and never be reconfigured. It's the ultimate lockdown. Now, let's just look at the consequences of what we just did. If we try to change the name, we get an error. Try to delete it, error. Try to use define property to make it writable again, you guessed it, another error. We've created a truly immutable property that's safe from any accidental or even malicious changes. So far, we've been tweaking individual properties. But what if you want to apply these kinds of rules to an entire object all at once? Well, good news, JavaScript has you covered. There are a few global methods that let you perform these operations in bulk. Let's take a quick look at how they work. Okay, there are a few of these methods, but the two main ones you really need to know are object.seal and object.freeze. So object.seal stops you from adding or removing properties, and it makes all existing properties non-configurable. Then you have object.freeze, which takes it a step further. It does everything seal does, but it also makes all existing properties non-writable. It's like putting your object in a block of ice, making it completely immutable. Alright, let's put all this new knowledge to work. One of the best ways to see the real power of property descriptors is to use them to create a perfect clone of an object. And when I say perfect, I mean a clone that not only copies the values, but also preserves all of those flags we've just been learning about. Now this is where things get really important. If you use a standard cloning technique, like a simple for-in loop, you are only copying the keys and values. You're completely ignoring all the flags. This means your new object will have all its properties reset to the defaults, writable, enumerable, and configurable, all set to true. And that can lead to some really nasty, hard-to-find bugs. But with a flags-aware clone, you create an exact replica of the original object, preserving all of its properties' behaviors. And the best part is, creating a flags-aware clone is actually really simple. It's just 3 steps. First, you use object.getProperty descriptors to grab all the property descriptors from the source object. And notice that S at the end of descriptors. This method gets all of them at once. Second, create a new empty object that'll be our clone. And third, use object.defineProperties to apply all of those original descriptors to our new target object. That's it. 3 easy steps to a perfect bug-free clone. So there you have it. You now have the power to control your object properties with a level of precision you probably never thought possible. But with great power comes great responsibility. So the final question I want to leave you with is this. When is using these features absolutely essential for writing robust, secure code, and when is it just over-engineering? The answer, of course, is going to depend on your specific use case, but it's a question that every great developer needs to ask themselves.